In this question, we want to find the derivative of this function using logarithmic differentiation. Our function is y equals 3x to the fourth minus 2 to the fifth over 3x cubed plus 4 to the second. Now, the reason why we might want to use logarithmic differentiation is because the function that we have is a little bit complicated. For example, in this one we have a quotient, so we would have to use the quotient rule to calculate the derivative. And within the numerator and within the denominator, we have expressions where you have to use the chain rule to calculate the derivative of those. And so it can get a little bit complicated when you combine the chain rule with the quotient rule or the chain rule with the product rule. Using logarithmic differentiation allows you to simplify the expression using log properties so that you have a much less complicated derivative to calculate. So the idea is that you would start off by taking the log of both sides, log of y on the left, do the natural log on the right, that would give you 3x to the fourth minus 2 to the fifth over 3x cubed plus 4 squared. And now that you've introduced the log into your equation, you now have access to all of the log properties. And there are log properties called the product rule for logarithms, the quotient rule for logarithms, and the power rule for logarithms, which will allow me to rewrite this expression on the right in a much simpler way. So on the left, I've got natural log of y, and on the right, I would use the quotient rule for logarithms. That would allow me to write natural log of the numerator minus natural log of the denominator. And then I would use the power rule for logarithms. And the power rule for logarithms allows you to take the power that is inside the log and make it the coefficient of the log. So I now have 5 natural log of x to the 4 minus 2. Same thing with this one, we have a power, and we can bring that power to become the coefficient of our log. So far we've done only algebra properties by taking the log of both sides and simplifying using the log properties. Now we're going to calculate the derivative. Now because I took the log of both sides, we took our original equation, which was an explicit form, and we've now turned it into an equation that is written implicitly. And so we're going to follow the idea of implicit differentiation to finish this problem. So I'm going to calculate the derivative with respect to x on both sides. On the left-hand side, the variables don't match each other. So I am going to follow the rule for calculating the derivative of logs. The derivative rule for natural log is that we do u prime over u. U is whatever is inside the log. In this case, that's y. So that is y prime over y. On the right-hand side, I have only x's. So I don't have to do any extra chaining when calculating the derivative on the right. So I'm going to carry down that constant multiple of 5. I'm going to follow the rule for calculating natural log, derivative of natural log, and that is the derivative of the inside over the inside. So the derivative of the inside would be 12x cubed over the inside, which is 3x to the 4 minus 2. Carry down that 2 as a constant multiple. The derivative of the inside is 6x over the inside, 3x squared plus 4. And I'll do a little bit of simplifying. That's y prime over y equals 60x cubed over 3x to the 4th minus 2 minus 12x over 3x squared plus 4. My goal was to calculate the derivative of y. So I need to solve for y prime. I'm going to multiply both sides by y. That would give me y times 60x cubed over 3x to the 4th minus 2 minus 12x over 3x squared plus 4. And because y was given at the beginning of the problem, I can substitute in for y that y is equal to 3x to the 4th minus 2, and that was to the 5th power, over 3x cubed. I think I've made a mistake that I'm going to have to correct, plus 4, 60x cubed over 3x to the 4th minus 2 minus 12x over 3x squared plus 4. Okay, so I think I've made a mistake in changing my 2's to 3, so I'm going to zoom out a little bit, try to find my mistake, and see if I can correct it. Okay, so right here at the beginning, I have x cubed, and then when I changed it here, I still had an x cubed, but then right here, I changed it to an x squared. So this should be a cube, and that means this part right here should be a cube. And when you calculate the derivative here, this should have been, instead of 6x, the derivative would be 9x squared. Okay, so then this would be 18x squared. This would be 18x squared. And this would be 18x squared. And then I also need to fix that 2. So this was an x. It should be x cubed, and I wrote it as x squared. So this as well, and this as well, and this one too. So those should be cube, cube, cube. Okay. Okay, so I can also see that I left off the squared here in the y. So we have 3x cubed plus 4 squared. And we have the derivative here, and this is the derivative written in terms of only x, which is an acceptable answer, but I'm going to go a little bit further and show you some canceling that can happen. So we can write this as 3x to the 4th minus 2 to the 5th over 3x cubed plus 4 squared. And what I'm going to do is get a common denominator between these two fractions. That's going to be 60x cubed times 3x cubed plus 4. I'm using the denominator of the other fraction, minus 18x squared, the denominator of the other fraction, times 3x to the fourth over 3x to the fourth minus 2. And this is all over our common denominator of those two denominators multiplied. 3x to the fourth minus 2 times 3x cubed plus 4. So what this does when you get a common denominator, it allows you to cancel one factor of 3x to the fourth minus 2 from here, making that 4 factors. And it allows you to combine these two factors of 3x cubed plus 4 together. So that's going to give you 3x to the fourth minus 2 over 3, and that's to the fourth power, and 3x cubed plus 4 to the third power. And then we just need to do a little bit of simplifying in the numerator here. So that would become 180x to the 6 plus 240x cubed minus 18 times 3. 18 times 3 would be 54 minus 54 x to the 6 minus 18 times 2 would be 36 minus 36. Now that's plus 36 x squared. And then we have a few like terms that we can combine. So that's 3x to the fourth minus 2 to the fourth over 3x cubed plus 4 cubed times 180 minus 54. $126, thank you, plus 240x cubed plus 36x squared. We wanted to go a little bit further. We could factor out an x squared. And these are all even numbers. Are they divisible by 4? No, they're divisible by 2. We can factor a 2 out. Make that 63x to the fourth plus 12x plus 18. Those are all divisible by 3. I can now make this 6. So this is 21x to the fourth plus 2x plus 3. I think that's about as far as I can go. Thank you for checking out my videos. Have a great day.